is, I am a singer at your voice. Okay, going back to the topic, electronic configuration part 2. I already discussed the overview and we will now go to the content. But before that, I have good news to everybody. Okay, through my extensive research, I found out that before there are only 118 elements in the periodic table, but now there are 119. The last chemical element was discovered in 2018. Wow, right? So this is called unioninium. Unioninium is the last hypothetical chemical element under eighth period. So these are the period of organism. Here, we have a periodic table here, right? You can see? Okay, so we count the period. The period means that is the horizontal rows. Okay, so let's count. 1, 2, 3, 4, 5, 6, 7. And the eighth period in the horizontal row in the periodic table is the organism family. And then this is specifically a hypothetical chemical element known as unioninium discovered in 2018. Now, after 2018, 2019, 2020, and 2021 to 2022, there is no chemical element discovered after that. So, the last chemical element, which is the unioninium, will be the basis of the incoming and the upcoming future elements that will be discovered so that it will become 120 plus. But for now, officially 119. So this is the present trivial present status of the periodic table, and this is not being reflected in the textbooks in universities and institutions all over the world because this is adopted 2018 Pasha, because most of our books are very old. Okay, unless they also do the upgrading system of their books, our reference textbooks. Okay, but normally they don't do that, right? Especially if the discoveries are very few. So it will take them more financial resources to do that, especially in the reproduction of those materials, textbooks materials for educational purposes, whether it could be in public educational system or private educational system, right? Okay, so that is the latest status of the periodic table, 119 elements. You get the point? Or something like that. So, based on my research also, that Dmitry Mendeleev, right, discovered the properties, the characteristics, how to arrange properly in terms of the atomic number of the periodic table. Okay, we found out also that there are only 94 naturally occurring elements. The rest are artificially prepared, something like that. But the 94 are naturally occurring elements. Okay? Or the norm. Naturally occurring, shall we say, radioactive metals. Okay? Radioactive is under also with the naturally occurring metals. Okay, that's only a specific radioactive. But what I'm trying to emphasize, it's been comprised with that 94. Okay? So if the question in the future will say, how many naturally occurring metals in the planet Earth? Your answer will be 94. And then how many elements now at the present status? Your answer will be 119. Okay? Like that. And it's also rare to have a question like this, what is the last chemical element discovered? Because this is just new, right, in 2018. So normally, we'll still follow the 118, unless it will be reflected in the textbooks already all over the world and circulated globally. But up to this point in time, it's not been yet, realized. Okay? So, or you can check that out, double check in your first year college students who take up chemistry right now, and also the chemistry students and senior chemistry in high school who took up chemistry right now, then you can also verify if the periodic table has already 119. But I doubt it's still 118 in the www, okay, internet or social media, whatever. Okay, now I just printed here the periodic table, right? So, this is very important, guys, because the electronic configuration will be basing in the elements. Okay, to get straight with you guys, electronic configuration is not applicable for a compound. It is applicable to element only. So we are still in the classification of matter study. If we try to go back to the flow chart when studying chemistry. Get the point? Because I need to be, systematized in my discussion. We need to follow the flow chart in our discussion. Okay, like that. This is all about element. Okay. Now, okay. Before going further with this electronic configuration discussion, we need to understand the atomic theory of John Dalton. Okay? So, who discovered the atomic theory? It is Mr. John Dalton. And after that, there's a lot of research that has been conducted, and Niels Bohr, found also another theory, which is the atomic structure also, but he included this electronic configuration, blah blah chuba chuchu, something like that, and the discovery of the nucleus and the elementary particles, whatever, chuba chuchu, like that. Okay, I will discuss further. Okay, I will now draw. Okay? Okay? Circle, circle. Okay, like this. I'm not really that good in drawing or in illustrations or schematic diagrams or whatever, so I will just try my best today. Okay? Okay, circle. O, ganon. Oh, this is the atom. One big atom. Ganon. And then there's another layer. Okay, ganon. And there's another layer also. Ganon. And there's another layer also. Ganon. So this atomic structure style was discovered by Niels Bohr. Neilsbohr. Well, let me say H. Basta Mr. Niels Bohr. Okay? The Bohr atomic model theory, something like that. Okay. Now, this circle here is what we call as the outermost shell. Okay, this one also. Nakita ninyo ang mga circle-circle galore? So this is the outermost shell also. Outermost shell. Outermost shell. Now we go to the periodic table here, class. Okay, in the left side. You cannot see, right? I cannot also zoom out. And then you cannot see. Zoom out, no, zoom in. Okay? So you cannot see, right? I will just discuss, right? Because I cannot do that. Okay, we have here the Group 1A elements. Okay, Group 1A elements. Okay, now, Group 1A elements have also charge of positive 1. Okay, positive 1. Now, this is also column 1, right? The column 1, the periodic table, will also represent the valence electrons in the outermost shell. You get the point? Valence electrons in the outermost shell. For example, the column 1. Column 1. So, column 1 in the periodic table, you should master this, guys, ha? Okay? Show you ko, mugawas din siya sa board examination. Sa physical and chemical principles, chemistry, physics, like this, blah, 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 so and so. Organic chemistry, inorganic chemistry, like that. Okay? Like that. So, column 1 is the alkaline metals. Alkaline. Okay? Alkaline metals. Okay? Metals. Now, you said you have an alkaline solution. Okay? So, usually, that would be sodium hydroxide, potassium hydroxide, cesium hydroxide, francium hydroxide, or lithium hydroxide. Because it's derived from the periodic table. That's why you call it alkaline. It does not refer to the acidity and the basicity substance. It refers really to the property and the arrangement or the configuration in the periodic table, which is column number 1. So, positive charge of 1 all. Okay, and at the same time, happens only that equal also the valence electrons in the outer shell. For example, this is the outermost shell in this drawing. Okay, like that. So the valence electrons will occupy here So let's say we put electrons, 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 electrons. So there is only one. So one electron. Okay, balance electron, one electron, one electron, one electron, one electron. And then this sodium will be here. Sodium, okay, lithium, rubidium, cesium, okay, francium. So all of these alkali metals will be here because they share the same valence electrons, but not the charge because it's dependent on their characteristic, how metallic or how non-metallic they are, or their chemical properties, something like that. But I am referring to the valence electrons in the outermost shell. So these are the shells. One, two, three, the non-shell. And then if there is another, after this first shell, actually shell is just an energy level. To be technical, it's just the same. So if there's under here, that will become sublevel. Actually, that is sub-energy level, but shortcut lang understood, sublevel or subshell. Ganon. English pa din, right? Because sub, meaning under. Okay, so, ganun na nangyari. So we speak of column 2A. This is comprises of beryllium, magnesium, calcium, strontium, barium, radon. Radon ba siya? No, it's not. Radium. Sorry, radium pala siya. Okay, nakakakalit. Let's review in the Lambda 9 series, radioactive substances. Wait. I have to prove. Maybe I'm wrong. Okay, no, I think it's radon. Sorry, guys. Okay. Hala. Really? Take note. I think there's a mistake on the periodic table. I got this in the Google search. Because I told you, sometimes Google searches have erroneous data. Take note, see in the 8A column, there's also A, and there's also RA in the 2A column. I doubt one of them is RN. Because there are only two. It could be radon and radium. But I doubt radium is radioactive element because it ends with IUM. This identification, for example, iridium, cesium, okay, like that. We have the uranium, right? Those are radioactive substances or elements that ends in IUM, something like that. But I doubt lang talaga siya. I think it's gonna be radon. Masipyat lang siya, guys, ha? Sa group 8A. Sa Google search ni siya, guys. I told you, not perfect. There are mistakes. Before also, I saw magnesium oxide. Wrong chemical formula. Okay? Something like that. Be careful with the Google search. Okay? Something like that. Okay, so there are two. Nakakaloka to. I will file a complaint. Charot! Okay, so for the column 2A, I think this is radium. I have no choice. Okay, so that is radium now. Okay, so column 2 is what we call as, okay, alkaline earth metals. So in your memorization galore, okay, meaning galore, style, system, methodology, strategy, scheme, technique. There's a lot of terms, right? Alkaline earth metals. So in your style of memorization, you will only add earth, but the same terms in the column 2, so that you have a faster and quicker memorization, so that it can accumulate in your brain cells. Something like that. And then in the column 2, we have a positive 2 charge. And then it just happened also that the valence electrons in the outermost shell are 2 electrons. Okay, now here in the second energy level. Okay, in the second level. Okay, in the outermost shell. So the valence electrons will exist here. There are 2 electrons here. 2 electrons, 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 2 electrons. And then the group 2 will be beryllium. Beryllium, they will share in this level, beryllium, magnesium, calcium, what's that? Strontium, like that, barium, radon. So, in this manner, so on and so forth, it will follow the pattern. Okay, meaning to say, it is highly systematized after that by following the column arrangement of the electronic configuration in the periodic table of the elements applicable purely to elements, not for compounds, not for mixtures, not for other substances, chuba. Ganon. Okay. So I don't have to discuss na the other, energy level or the shell or the outermost shell. It's understood, right? Okay, I will erase. Okay. Now, okay, I have to say this very important topics and key terms that usually examinations will be happening, and they will just put this every time. Not all, but sometimes only when it will come out, only two, like that. So we need to have this. The first one is the octet rule. Okay? Like this. What's the time now, mga palangga? Oh my gosh! Octet rule. Okay. And then we have also the Pauli exclusion principle. Wow. Pauli exclusion principle. Okay, this is basic foundation, guys, okay, gathered all the basic foundations because this is really the foundation in order for you to pass future examinations, okay, like that. So we have the off-bow principle, okay, off-bow principle, okay, like that. Now, the octet rule will be more based on the chemical bonding. Chemical bonding. Okay, chemical bonding. Okay. And then the Pauli exclusion principle, the off-bow principle, will be more on the electronic configuration. Electronic configuration. If you don't understand the theory of Pauli exclusion principle and off-bow principle, you will get lost. Because this is the requirement to understand properly the electronic configuration topic of chemistry, like that. And then you can also understand very well if the chemical bonding, if you don't have that knowledge of octet rule, okay, meaning referring to the valence electrons in the outermost shell, okay, during the sharing of electrons and transfer of electrons, something like that. Okay, if you don't know this kind of role, okay, which is specifically the Lewis dot structure. That's structure. Okay, I always emphasize this in the discussion. I think yesterday or 2 days ago. So that's ganon. So this represent the electrons. Okay, and this gas refers to the valence electrons. For example, I have the carbon. Sometimes others also will be confused, including me before when I was in college. Okay, I think first year like that or third year. I'm confused with the characteristic of a carbon. Really, I want to read to what's this carbon all about? This is a metal or non-metal? And then I studied it a little and then oh my gosh, it belongs to the non-metal pala siya. But it looks like a metal. Okay, because when you burn the wood, plastic, rubber, or any type of materials, it will produce carbon atoms. Why? Because most are made up organics. An organic composed of carbon, hydrogen, and oxygen. So carbon will always present whatever materials in the planet Earth you are trying to burn. That's the point. Okay? B-U-R-N, not born na tao. Burn. Okay? Something like that. How can I pronounce? Burn. Ganun. Burn. Kasi B-U-R-N, diba? Like that. So, carbon atoms will always appear. Okay, guys? Okay. So, that would be our discussion for that. Okay. So, ang carbon pala guys is non-metallic properties because in the rightmost part. Okay, according to scientist Dmitry Mendeleev, as you go to the right from left or from left to the right, it will decrease the metallic properties of any elements of those 118 elements in the periodic table. So it is very sure that carbon really undergoing a property of being a non-metallic. And what we are trying to emphasize here is the valence electrons in the outermost shell of carbon, which is 4 because it belongs to the 4A family. Okay, 4A family, okay, 4 electrons. I have to put this, 4 electrons. 4 dots represent 4 valence electrons in the outermost shell, katong circle that I've illustrated a while ago. Something like that. Okay? I don't have to explain that further because I already discussed chemical bonding last 2 days ago, right? Okay. Going back to the discussion. We will now focus now for the electronic configuration, but I'm very, very talkative. That's why it took me a lengthy moment to discuss it here. Okay, I have to cut this and I'll go back again with you guys. Stay tuned. If you want to like and comment and share this video, then you can subscribe my YT channel if you want also, and then you can click the notification bell for some news updates. So I am a singer, eternal voice, your YouTube content creator, your social media influencer, and small YouTuber. Bye bye. God bless everybody. See you later.